online?
Yeah, illegible.
Like this is, y'all hear that?
Yes.
Okay, so it's that mic. Couldn't remember if I plugged it in. Okay, we're there pretty much. So this is going to be, let's see, I'll distribute the 2 through. Then, I hope this is obvious, antiderivative, this is just itself, right, e to the u. So I'm going to have 2u e to the u minus 2 e to the u plus c. And then one more step, I need to replace u with what u is, which was square root of x. So 2 root x e to the root x minus 2 e to the root x plus c. Yeah, this is fun, right? So, you know, that's another example where we did something completely different in the beginning, right? We did a basic u substitution, and then it turned out to be an integration by parts problem. And things are going to start to build like this as we proceed. As we learn these other techniques, we're going to see, oh, we're going to be doing a problem later, and we're going to be like, oh, but that's just this integration by parts problem, that we can handle that. Was there a question?
Yeah, it seems to have cleared up, but there was quite a bit of static or rubbing the mic or something.
Oh, was there? Okay.
Yeah, it's better now.
Okay. Yeah, y'all just let me know. All right. We happy? Okay, I'm not done. I have one more thing I want to show you. And then at that point, it's going to be practice, right? You just have to go get your hands dirty. I wanted to mention to you all, you know how there's homework solution videos that I have for this class? So being a human, I did make mistakes when I was doing those sometimes. And I did correct them back when YouTube used to let you do a little pop-up, little bubble that would pop up, and you'd have a note. And so I already knew about all these, you know, any mistakes I had, I knew about them. And so a bubble would pop up. It would say, hey, that was supposed to be a 2, or, you know, whatever. And then YouTube got rid of those. So then they all went away. So all these things I fixed went away, and I never went back and fixed them again. So I know that there are little mistakes in different places. Students will point out. Look in the comments. If there's ever been something, I put a comment down on the bottom saying, hey, on this problem, you know, problem number 5, I forgot the negative sign or something like that. But if you see something that is incorrect and there's no comment on it, let me know. And that way I can add the comment to it. All right. Which one are we going to do? So I would like for you to take out your formula sheets if you have them. If you have your formula sheets, well, you know what? I don't think, you know what, they may not be there. Yeah. So look, I'm looking at the back of the book. And this book is mine, so I never tore out the pages in the back. The pages you're allowed to have on the exam that I've provided to you on Canvas takes you up through page 6, reference page 6. And if you look at that now, you'll see there's a bunch of formulas for antiderivatives of things here. But the book actually continues page 7, page 8, page 9. And I've seen like textbooks that are all just formulas for antiderivatives. Like, because, you know, back in the day before computers, we didn't have the ability to do that. So people would go figure out general formulas. There's one formula on here that's kind of interesting that I want to talk about. And I want to actually show you the formula, where it comes from. And it's not on your formula sheets on Canvas, so you would have to have the whole book or all these formulas, but let me just write it down here. Now let me get my glasses because I'm getting old. Okay, a few years ago I was welding in my garage, and I have one of those welding helmets that that automatically blacks out. I don't know if you know anything about welding, but it automatically blacks out as soon as you hit the spark or whatever you get. Well, I was sitting there welding for a while. I realized the helmet wasn't working. And so, like, I was finished, and I had this, like, huge, like, bright light, like, white spot in my vision for a while. So I thought that I had fried my eyes because the white light went away. But, over the next few weeks, I couldn't read the side of medicine bottles and things like that. And so I went to the eye doctor, first time in my life ever needing the eye doctor. And I was like, I was welding the other day, and now I can't read small print as well. So he looked at my eyes, and he's like, no, you have no damage. You're just getting old. I said, okay, that sucks. And he goes, it's just going to get worse and worse each year. And so he's right. What's that? Yeah, hold on. Is it cosine of u? Are you asking me? Or yes, that's cos u, yeah, sorry. All right, so this is what we call a reduction formula. All right, it's a reduction formula. So I'm going to show you first how the formula is used, and then I'm going to show you where it comes from, okay? So as an example of how you would use this, if you wanted to take the antiderivative of sine to the third power of x dx, let's say you wanted to do this. This formula allows you to rewrite this integral with this new expression, and notice what happens to the power. That's an n minus 2. Sorry, that's n minus 2. So let's just use the formula here. N is 3. You'll see that? N is 3. So we get negative 1/3 sine what? 3 minus 1, right? So sine of 2x cosine x plus, let's see, 3 minus 1 is 2, n is 3, integral sine to the n minus 2, n was 3, right? So 3 minus 2 is 1, so this is antiderivative of that, dx. Well, I'm using x for the example. The formula has u in there, but I'm just using x. So look at how this worked. We want to know the antiderivative of sine of cubed x. According to this formula, it's this plus this, blah, blah, antiderivative of this. But that is easy, right? Antiderivative of sine is negative cosine. So we could just, next line would be negative 2/3 cosine x plus c, and then everything else would be the same, right? Now, let's say that this would have been, any questions there? Because I want to just kind of copy on top of this. Okay, so let's say that this would have been the 30th power instead. Then what would change? This would be 29, right? This would be, this would be 30. This would be 29 over 30, right? And this would be sine to the what? 28th power, right? And so now you go, crap, I don't know how to do that, right? Well, guess what? You just use the formula again. So that means that this piece right here would be all of this replacing n with 28. And then your last integral would have a 26, right? So then that one would be replaced with this again, and then your next integral would be 24. And so you could keep using this formula to do any really any power of sine, right? Now, I'm not saying it's nice, okay, if you had a high power, but that's the way the formula works. You keep on kind of chipping away at the powers each time until you get this down to something you can do, all right? Now, where does the formula come from? So let's see if we can figure out where this formula comes from. This is called a reduction formula. A reduction because it's reducing the power on the sine each time. It reduces it. Your original integral has sine to the n. Your new integral is sine to the n minus 2. So there's been a reduction of the power. All right, so here we go. What I'm going to do is write the original integral down. And just for the sake of making this a little easier for us, I'm going to use x instead of instead of u, all right? Now, I'm going to do integration by parts. But before I do it, I'm going to do something clever, which you would never think to do. I don't mean that as an insult. I would have never thought of it either, okay? I mean, have y'all heard that quote by Newton? If I've seen farther than others. Have you heard that one? No. So Isaac Newton had a quote. It went, and I could be off by a word or so here. He said, if I have seen farther than others, it is only because I have stood on the shoulders of giants. Okay, was that?
That's good.
Yeah, so in other words, look, I'm not saying I'm Newton, number one, but it's not like I would ever thought of this either. Like someone showed this to me, right? So knowledge requires that, I mean, you have to think about calculus as thousands of years of human thinking, right? And then we're going to sit here in 16 weeks and absorb all of calculus. You know, it's just like you have to concede that you need to see things. You don't have a lifetime to spend trying to figure this out. Somebody did. Well, they didn't have a lifetime, but you know, back in those days before, when this was the leading edge of mathematics, somebody was spending their career working on things like this, trying to come up with an approach to attack a certain type of problem. Okay, here we go. So I'm going to rewrite this as sine to the n minus 1 of x times sine x dx. So all I've done is this. If that's making you like unhappy, if we had x to the n, let's say, all I'm doing is rewriting x to the n as x to the n minus 1 times x to the 1. It's the same thing. If I put those together, you add the exponents and you get x to the n, don't you? So that's all I'm doing here is rewriting sine to the n of x as sine to the n minus 1 of x times sine to the first power of x. If you put these two together, you get back this. Agreed? But what this allows me to do is an integration by parts table. So my integration by parts table will look like this. U is going to be the sine to the n minus 1 of x, and my dv is going to be the sine x dx. That fair? Let's do the antiderivative here. This one's easier. The antiderivative there is negative cosine x. And then the derivative of this, be very careful, okay? The derivative of this, I'm going to need a little space here, is going to be, well, chain rule, right? Imagine this was sine cubed x. The 3 would come out first and then be sine squared, right? So here we're going to get an n minus 1 out, sine to what power? So this comes out, the power comes down by 1, so n minus 2, right? So I'm subtracting one more power from that of x. Am I done? Chain rule. What is it? Cosine x times cosine x dx. If that's bothering you again, just imagine you had sine cubed x and you took the derivative. That'd be 3 sine squared x times cosine x. That's exactly what I'm doing, but instead of 3, I have n minus 1. So that came out, subtract 1 from it, cosine, there we go. Okay? This way? Okay, here we go. Okay, so here's where we are. We are at ultraviolet, these two multiplied. So that gives me a negative. I'm going to put the sine to the n minus 1 of x first, then the cosine x, and then minus integral. So that's ultraviolet minus voodoo, which are these two multiplied, right? These two multiplied. When I multiply those two, I get, I get a negative, right? And then I have an n minus 1, which is a number. Okay, so negative n minus 1. I have this sine to the n minus 2 of x. Then I have a cosine x. Then I have another cosine x. And then I have a dx. So I hope you agree with me that this times this is everything you see there. Yeah? Okay, all right. I get time to clean this up. This is negative sine n minus 1 of x times cosine of x. Okay, this can become plus n minus 1 integral sine n minus 2 of x cosine squared x dx. I'm going to erase that. So I brought the negative n minus 1 to the outside, and that changed it to a plus n minus 1. And then this is just this, and then cosine is cosine squared. So that's where we are, right? Any questions there? Now this integral is no good, all right? Because we can't do anything with this. And it's not this, is it? Okay, so next step, this is a cool step right here. Keep in mind the good old Pythagorean identity. Sine squared x plus cosine squared x equals 1, right? So I can solve this for cosine squared x equals 1 minus sine squared x, right? So I'm going to replace that with 1 minus sine squared x. Now I'm going to just save myself a little time here. Like that. Now you might be asking why. Like, why would you do that? Okay, why would you do that? Let's just keep going. Okay. So here to here, here to here. Let's see what happens when we do that. If we distribute through. By the way, what I'm showing you right now is not something that I would ask you to do on a test, unless it was a bonus question. Because I would ask you to verify this reference formula. Show it's true. Okay, integral, here we go. So when they're first multiplied through, we get sine n minus 2 of x times 1, right, which is itself. And then I have minus, now what happens when you multiply those two together? Add the exponents, right? What's n minus 2 plus 2? N, right? So you just get sine to the nx dx. You all agree? Now, I can split this up into two integrals because I have subtraction between them. So I'm going to do that, I think, right here. So this is, yeah, one of the drawbacks of being in classes, you'll have to see around me. Okay, let me do it this way. This is going to split into two integrals, so the n minus 1 is going to have to hit them both. So the first integral will be sine to the n minus 2 of x dx. And then I have minus another integral, which is this one, sine to the n of x dx. Do y'all see why I did that? Does anyone see why I'm splitting it into two? There's a reason why. Do you recognize this? It's the original problem, isn't it? Right? And so can't I move that to the other side again, like I did on that one weird problem that we had earlier? I'm going to do it, but let me write something down here. Okay, next line. Here's what I'm going to do. I'm going to remember this. What we're saying this is equal to, the original problem is equal to all of this minus sine to the n minus 1 of x cosine of x plus, okay, I'm going to distribute the n minus 1 through to both of those. So it'll be plus n minus 1 times the integral of sine to the n minus 2 of x dx. And when I distribute it through to the next one, here to here, I'll get minus the n minus 1 integral sine to the n of x dx. I know this is crazy, all right? I realize that. So as I said, this right here is the same that's over there, right? So I need to move this over. How can you move it though? Be careful. On the previous, if you look back at what we did on the previous one, we had like minus the integral, and so we added the integral on both sides, right? If you divide, you have to divide each of these, right? So we want to get rid of this. How about we add, why don't we add to it this many of them? Right, so like if this said negative 10 of these, right? I would add 10 of them. If it said negative 2, I would add 2, right? So I've got to do that here and on the other side. So I'm going to add n minus 1 of those integrals. It goes away over here. How many of these do we have? How many are here? How many apples do you see here? 1? How many do you see here? N minus 1 of them. So it's just n of them, right? You have 1 of them plus n minus 1 of them, which would add up to be n of these, right? If that was 1 and this was 9, this would be 10. Okay, so we have n of those, right? We have n of these, so that'll be my next line. I'm almost done. We are really close to being done here. Okay, so what we have now is that n of these integrals is equal to this negative sine to the n minus 1 of x times cosine of x plus n minus 1 of these integrals where it's sine to the n minus 2 of x dx. So that's just all of this rewritten. You see the last step? Look, we're almost here. We're almost here. Look, this is almost this, right? I'm missing that n and that n right there, but that comes from this right here. So I divide everything by n. This becomes a minus 1 over n, and then this becomes n minus 1 over n. That's the formula. So it's the reduction formula for sine to a power. What happened to what? Right here. So this is one of these integrals, right? I have one of these, and I'm adding it to this. And so it's n minus 1 plus 1. The ones go away. Okay? So there are all sorts of reduction formulas, all right? There's a bunch of them out there. So I'd like to challenge you to a bonus question. Now, this is not necessarily super hard. I'd like to see if you can get this on your own, though. You know, I know there's all sorts of stuff I'm sure you can find online. But see if you can get this on your own. I better copy it down right, or else you're going to be pissed off at me. When I was in graduate school, I was taking this class. What class was it? What class was it? Can't remember now. It was, I know my professor, Dr. Wilson, but anyway, in this class, most of the exams were take-home exams. I mean, almost everything in grad school is take-home. So there's this test that we were given, and we were given like a month to do it, and it was like 5 problems or something. And I'd been working on this problem for like weeks and weeks. We had to prove a theorem, or prove this conjecture. And I was working on it, and I actually got to the point where I was like, you know what, I can disprove this. You know, like something ain't right here. And so I came up with like, in math, if you ever have a statement that you think is true, the easiest way to disprove it is to find an example where it's not, right? That's called a counterexample. So if I say like, you know, if I say everybody in here is wearing a mask, right? Is that true? How do I disprove it? I find who's not. You know what I'm saying? Like, it's just easy to disprove something. It's harder to prove it. So we were supposed to prove something, and I actually had found an example that disproved what we were supposed to prove. And then I was like, oh man, you know, so this professor was like really known for not being very student friendly. Like you couldn't ask questions during class. You know, it was just like he just came up there and spewed out the information. He was great, don't get me wrong. But he was kind of mean. So I went to his office and I was like, you know, nervous as shit. I walk in there and I'm like, sir, you know, here on this problem, you wanted us to work this out, and you know, here's the problem, and you know, here's my counter example. And I was like, if the theorem had stated this instead, then here's a proof. Like then it would work. And so he picked up the test and he's like, oh yeah, that's a typo. And he goes, tell the rest of the class. So anyway, the point is, I try not to make typos on things that are worth credit in the class. So it was just like, he just went on with his day. I had put weeks and weeks into this work, you know, and he was just like, oh yeah, carry on. So here we go. We want to prove this. There we go. So this is going to be a bonus problem. And I would collect that with the test, which is supposed to be on Monday, right? So what are we going to do Monday? I know there, you know, I have students that are at home, right? We've got 9 people at home, or 8 at home, and we've got 10 here. So, I mean, I don't think it's fair to do at-home test and on campus. I don't think that's fair at all. And we all signed up for face-to-face. So I think for the exams, I'm going to need people to be here. All right. Now, I know there are certain students that I've talked to that maybe there's something with, you know, if you've been in contact with someone with COVID, there are going to be exceptions, but I want to do that exception by exception. This whole idea of like me streaming the class and doing this together is just to help students out who maybe don't want to be here every day that they, if they can avoid it, they're going to avoid it. All right. So let's plan on Monday being here to take the test. I gave you a review. All right, so you just want to make sure you go through that. You want to look at the problems. You want to see what you can do with it. And I know y'all are going to want an answer key. I know you're going to want an answer key. I don't know. Just leave today assuming you're not going to get one. If you get one, great. If you don't, you don't, okay? I think the review itself is a gift because in Cal 2, I mean, just expecting to have a review for a test is not necessarily something I think is a universal given in a Cal 2 class. So we'll come in here on Monday, paper, pencil, everyone will be spread out, and we'll take a test, our first test. Any questions?
About showing up in person. So can we get checked for COVID before the class, or do we have to show up to a scheduled?
Okay, so as far as I know about the actual testing for COVID, you're supposed to do it once a week. I personally was not tested before I came here because they're not even, I don't think they're even open today for testing.
They are.
They are now?
Wait, actually, no, not on Wednesday.
They're not on Wednesdays. So this is my first day on campus. There's no way I could have gotten tested unless I came here on a day that I'm not supposed to be here. So I would say if next week is your first time here, right, then you shouldn't need to be tested. You can just come in and take the exam. If you're going to return back though on Wednesday, they're somehow keeping track of this, so they're going to want you to get a test.
They're keeping track of it because you have to register to take the test, and so they have that whole log of people who came there.
Yeah, they're keeping track of who's tested. Now you do have to do a health screening before you come here, which is just, you go on a little website that I sent to y'all. You just say, oh yeah, I haven't been in contact with anyone, I don't have any symptoms, blah, blah, blah. And then when you come to the campus, you just show them that and they'll give you a wristband and they'll let you walk on campus. But it's just a verbal like, yeah, I'm good, and they take your temperature and that's it. It's not an actual test. Does that make sense?
Yeah, I was wondering if I'd have to come by tomorrow and get tested and then show up Monday.
I would say, yeah, for everyone who's at home, that you come on campus, take test Monday, just come to the class.
Does the test have to be from at the school?
As far as I've been told, that they will accept others, but I don't know for sure. That I don't know. I've heard that they will.
And then one more question.
Yeah.
During exam day, is it just like we go take the exam and then it's over? Or
Then you're out. Yep, that's it. It's just come, take the test, you're gone. Yeah, y'all are free to go if y'all don't have any questions. Thank y'all for being here. Appreciate it. Yeah, I'm just kind of playing this out to see how this goes with the camera set up in here and see, you know. I mean, it would be nice to not have to stream, but, you know, I do want to accommodate those students who can't be here. It might just come down to where I'm not streaming live. I'm playing it back maybe, but I don't know. I don't want to paint myself into a corner right now.
once again, I want to thank you. Appreciate it.
Yep. Yes.
I'm gonna try.
The times.
Monday, 8:30 to 10.
Yeah,
Before here, but I can't guarantee I'm gonna get.
I'm going to try the same thing.
You're gonna try the same thing?
Yeah, so we'll see what happens. Yeah.
Okay.
Yeah, so I would say if you're standing there and it's coming close to test time, just get here. Yeah, because nobody's going to stop you from coming in this room on Monday. Yeah.
So for this week, like if we're not returning on campus for the rest of the week, should we even bother like coming back to teach stuff?
I want to say no, but I can't for sure, because really you were here on a day that they're not testing, right?
Yeah.
So you'll be back on Monday, and they test on Monday. So you'll deal with it then, and if you can't make that, whatever. But I think you have a legitimate reason for saying, hey, you know, I don't know, I can't, I'm going to do the same thing. Let me just put it that way. I'm going to just come back next week and try and get tested next week. That's what I'm going to do.
Sounds good.
Yeah.
Sounds good. Thank
Okay. All right. Question?
I saw I got here late. Because when I was leaving at the campus, I remember I saw the testing room, and originally I had gone there.
Ah, okay.
And then when I looked at it again, I was like, okay, that's testing.
Ah,
This is
yeah.
the actual class.
Okay. Yeah. No problem. Don't worry. I'm glad you were here. Good. I'm glad you were here. That's the most important thing.
Thank you, sir. Have a good one.
You too. All right.
Also, is the test open note?
No, it's only the formulas off of Canvas.
Sounds
Yep.
good.
Yep.
Thank you.
All right. Other questions?
So I've been testing negative. So I'm feeling like I have no more symptoms, anything like that.
Yeah.
Can I try and come Monday?
Okay. Just let me know if for some reason you can't be here. I totally understand, and we'll work something out. Just try and